Today we're going to discuss Newton's law of cooling. Newton's law of cooling states the temperature of a heated object decreases exponentially over time toward the temperature of the surrounding medium. And the formula that represents that is UT equals capital T plus U sub 0 minus capital T times E to the KT. Okay, so in order to do these problems, we have to know what each one of the letters mean. This capital T is going to be the temperature of the surrounding medium. That's usually the room temperature or the temperature of an oven, something that's going to be constant the whole time. The initial temperature, which is your U sub 0, is what the object was started being heated at, like what it was heated before it started to cool. K is going to be a negative constant, and this U sub T is our new temperature. So starting temperature, temperature of the surrounding room, new temperature. So this is where we started, starting temperature. This is my new temperature, or you can call it the ending temperature. All right, so we're going to do a couple examples. So example 1, an object is heated to 100 degrees and is then allowed to cool in a room whose air temperature is 30 degrees. If the temperature of the object is 80 degrees after 5 minutes, when will its temperature be 50 degrees? All right, so let's go identify a couple of things. The air temperature in the room. This right here is my capital T. The object is heated to 100 degrees. So this is my initial temperature. And then we know the temperature of an object is 80 degrees. So this is the UT after 5 minutes. Okay, so with this information, I can plug it in and find the rate at which my temperature is decreasing. So the formula that we're going to use again is U sub T, so my ending temperature is equal to the room temperature plus the initial temperature minus the room temperature times E to the KT. All right, so I know that the ending temperature right now for the first part is 80. I know the room temperature is 30. The initial heated temperature is 100 minus the room temperature times E to the KT. Well, T is 5 minutes, so 5 and then K. So we're going to use exactly what we did yesterday in order to find the K. So order of operations is I'm going to subtract 30 first and get 50. 100 take away 30 would give me 70 E to the 5K. Yesterday when we were doing problems just like this, the next thing we would do is divide by 70. After we divided by 70, we'd say, okay, I'm trying to find out what this exponent is, so we're going to ln both sides. When you ln the right, the 5K pops out front. We said yesterday that the ln of E is just 1, so 1 times 5K is just 5K. The last thing I need to do to get K by itself is divide by 5. So K is going to equal the ln of 50 divided by 70 divided by 5. So I'm going to type that in my calculator, the ln of 50 divided by 70 divided by 5. And I get negative 0.0673. Again, I'm going to go 4 places out. Negative 0.0673. Okay, so now that I have K, I had to do all that work to find K. Now that I have K, I can go answer the question. They want to know when will its temperature be 50 degrees. All right, so I want to know when. So I'm looking for T, be 50 degrees. So this is going to be my new cool temperature. So where I had 80, I'm now going to go put the 50. The room temperature did not change. The original heated temperature did not change. The only thing that changed is I want it to cool to 50 now, and I know my rate. And I'm looking for T. So we're going to subtract 30. We're going to divide by 70. We're going to take the ln of both sides. The ln of E is 1. Then I'm going to divide by my K. So when I type this in my calculator, I'm going to have the ln of 20 divided by 70 divided by my K, which is negative 0.0673. So it's going to take about 18.6 minutes to cool to 50 degrees. That's it. Okay, let's go do another one. So this next problem is a party. It says, in preparation for the end of year feast, a pig whose initial temperature was 75 degrees is placed in a large oven at noon. At 2 p.m., Harry and Ron checked the pig's temperature and found it to be 100 degrees Fahrenheit. If the oven's temperature remains at a constant 325, at what time will the feast begin, assuming the pig is done when it reaches 175? All right, so let's talk about our formula again. So our formula says the ending temperature is going to be equal to the room temperature, or in this case, the oven's temperature, plus whatever the initial temperature was, minus the oven temp, times E to the KT. All right, so right now I know I have an ending temperature of 100 degrees. The oven is 325. My initial temperature was 75 degrees minus the oven times E to the KT. How long did it take me to get from 75 degrees, my initial temperature, to 100 degrees? Well, we put it in at noon. I took a temperature at 2, so it took 2 hours to get to that temperature. So we're going to go find K. So we're going to take 100, take away 325, I'm going to get negative 225, equals 75 minus 325, negative 250 E to the 2K. We're going to divide by negative 250. So we get, when I divide, my negatives are going to cancel. I have a 2K up here, so again, just like the last problem, we're going to ln both sides. The ln of 225 over 250 equals 2K ln of E. The ln of E is 1, so to find K, I divide by 2. So K is going to equal, so we're going to do the ln of 225 divided by 250 divided by 2. And we get negative 0.052, I'm going to round that to a 7. So negative 0.0527. We found K, now we're going to go answer the question. So the question wants to know, if the oven temperature remains 325, at what time will the feast begin, assuming the pig is done when it reaches 175 degrees? So I've got a new ending temperature. So we have a new problem. So my new ending temperature, right here where we've had the UT, okay, it's going to be 175. And then everything else is just like it was before. So it equals the oven temp plus the original temp minus the oven times E to the, now I have my K, it's negative 0.0527 T, because now I'm looking for the time. All right, so same process. 175 take away 325 is equal to negative 150. This right here, when I subtract them, is still negative 250 E to the negative 0.0527 T. Okay, so we're going to divide by negative 250. My negatives are going to cancel. So we're going to have 150 over 250 equals E to the negative 0.0527 T. We're going to ln both sides. When I ln the right side, the exponent comes out front. We've said over and over and over, the ln of E is 1. So the last thing I have to do to figure out the time is divide by the K. so let's go type that in the calculator. We've got the ln of 150 divided by 250 divided by my k, which is negative 0.0527. And we find out that it's going to be 9.6 or 9.7 hours. All right, so a couple things you have to think about. They really aren't asking me for how many hours, they're asking me about what time. So I know it's going to be 9 hours, and to change 0.7 to minutes, I have to do 0.7 times 60. So, and 42 minutes. So we put the pig in at noon, so 9 hours and 42 minutes later would be at 9:42. It's going to be a late party. All right, last example. So our last example is going to be very similar to what you're going to see on your assessment. We are going to figure out at what time what time did the victim die. So it says the detective is called to the scene of a crime where a dead body has just been found. She arrives at the scene at 10:23 p.m. and begins her investigation. Immediately, the temperature of the body is found to be 80 degrees. The detective checks the programmable thermostat and finds that the room has been kept at constant 68 degrees, so there's my capital T, for the past 3 days. After evidence from the crime scene is collected, the temperature of the body is taken once more and found to be 78.5 degrees. All right, so this was the first temperature, this is the second temperature, and this is the temperature of the room. So let's go ahead and find our K, because we're going to need that. Okay, so to find K, I have what it's cooled to, so this is my ending temperature. So 78.5 equals, all right, next we always have in our formula the capital T, which is the room temperature, plus the initial temperature the body was taken at, which was 80. Okay, and then minus the 68, e to the, we need the KT. Well, how long was it? It says this last temperature reading was taken exactly 1 hour. So my time is just 1 hour, so it's just 1. So finding K should not be that big a deal. All right, so we're going to take 78.5 and subtract 68. I get 10.5 equals 80 minus 68 is 12, e to the K. We're going to divide by 12, just like we did earlier. And we get e to the K equals 10.5 over 12. So we're going to ln both sides. So the ln of 10.5 over 12 equals K ln of E. And the ln of E is 1. So all I have to do to find K in this problem is just take the ln of these two numbers. So the ln of 10.5 divided by 12 is negative 0.1335. Okay, so that's the first part. Now we need to figure out at what time was the did the victim die. So the initial temperature is still not going to change. Oh, wait a minute, on this one it is. Okay, so the initial temperature of a human body is what? It's 98.6. They told me right here in this problem. And this is going to be the temperature they found the body at. So we're switching them up this time. So we found the body at 80 degrees. The room temperature is what's not going to change. Okay. The initial temperature of a body is 98.6. We're going to subtract the room temperature again. And I'm going to have e to the, I know my K, negative 0.1335 T. All right, so here we go. We're going to do some subtracting. So 80 minus 68 is going to give me 12. Then I have 98.6 minus 68. That's going to give me 30.6. E to the negative 0.1335 T. Okay, so we're going to do our division. 30.6 30.6. We're going to take the ln of 12 divided by 30.6. My exponent's going to come out front, so negative 0.1335 g ln e, which is just 1. I'm going to divide by my k. So the time is, so we're going to take the ln of 12 divided by 30.6. We're going to divide that by my k, negative 0.1335, and we find that it's going to be 7 hours and 0.01. So 0.01 is negligent. So it was 7 hours. Now remember, it was 7 hours before she found the body. She found the body at 10:23. So I need to count backwards 7 hours. So if I count backwards 7 hours from 10 o'clock, that's going to put me at 3:23 p.